This is problem 1.62e. It's on page 50. The figure P162 shows the shape of a slug to be punched from a sheet of steel 0.194 inches thick. Compute the shear stress in the steel if a punching force of 45,000 pounds is applied. Now the shape that they've given us looks something like this. Rounded section at the back. It's symmetrical about the center line. And this is a pretty straightforward problem because all we're supposed to do is calculate the shearing stress. Well, since the area that's being stressed, if you were to look at it from this direction, it would really just look like this. You'd see this line here, and you might see this tangent line, because that comes around as a tangent line. Anyway, the area that's being stressed is this area, of course, on this side, on the other side as well. So it's all that area around the perimeter that's being stressed. Anyway, since the force being applied would be this way to punch this piece out, and that force is perpendicular to the normal of any of these surfaces, then it's going to be a shear stress, and basically we just need the force over the shear area. So the shear area, I've drawn some of it here. Of course, it's 0.194 inches thick, but we need this perimeter length as well. So what I did is I decided to calculate the area as the perimeter multiplied by the thickness. Okay, so this is a T for thickness. So we already know the thickness T, it's right there. But we need that perimeter. So to calculate the perimeter, let me get rid of some of this. You understand what we're doing now. To calculate the perimeter, what I did is I realized, well, I've got a length here and a length here. Now the dimensions we're given are essentially this dimension and this length. And so what I did is I took, for this section, perimeter equals, there's two of them, this side and this side, square root of 0.4 squared, which is that distance, plus 0.6 squared. So I'm just using this distance here. This is 0.6, there's 0.4. That gives me the length of one side. So it's just Pythagorean's theorem because that's just a little right triangle. Now, then we have to add two of these lengths, and each of those sides is 1.6 inches long. So let's see, so 2 times 1.6 inches, that takes care of this little section. And then this area back here, or this length, is going to be half of the perimeter of a circle. So plus pi, if you multiply pi times diameter, you'll get the whole circle. I don't want that, I want half of that. So I need to multiply pi by the radius, and that'll give me this half distance. And that half distance is again 0.4. I've already used that dimension over here. Now all of these, here, 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 and here, these all have units of inches. So when you plug this in your calculator, you'll get about 5.899 inches of perimeter length. So then to calculate the area, when you plug that 5.899 inches by the 0.194 inches in your calculator, then you'll find that this is about 1.144 square inches. So that's that area. If you look at this from the side, that's what you would see is that area. It's a little over a square inch of area. And so now to calculate the shearing stress, it's just the 45,000 pounds force that's being applied in this direction divided by the shear area, which is all around this perimeter, and that's 1.144 square inches. Almost out of space there, so I'll just write it down here. So that's 39,300 psi. Now this is a lot more shear stress than most materials can take, so it's going to punch this out quite easily.